doing film sound, and also a teacher at the Danske Filmskole, National Film School of Denmark. And as a content maker, when new formats arrives, there is always this discussion about how do we transport this format between different platforms, how do we do deliveries, and how will the consumer receive it. So I remember when 5.1 broadcast started and obviously ended here in Denmark. One of the reasons it failed was that there was 46 companies that sold cable TV, and they all had this different set-top box with a different interpretation of which order the 6 channels should have. And at the people houses, there were some really strange listening experience going on. So when I some years ago learned about the Orpheus project and the AEM format, I was very happy there were actually people trying to do something with these classic problems. So the listening experience actually is same or very close to what's intended, and not have interesting issues like dialogue is going down in the subwoofer and things like that. So we start with the one who actually was a part of the European Broadcast Union's Orpheus project, Matt Furch, who is a leading part of the audio team in BBC Research and Development. The screen is yours.
Thanks. There we go. Hopefully you can see that. Right, yeah, so hi everyone, I'm Matt Firth. I'm a project engineer in the audio team of BBC R&D, and I've been with R&D for about 7 years now. Specifically, I focus on production, and this covers the tools and workflows we need for so-called next generation audio, or NGA. I'm going to be talking about the audio definition model, or ADM, which serves as a metadata model for NGA content. Then later I'll be talking about one of the tools we've been developing to author NGA content using ADM, and we call that the AEM Production Suite. I'm not sure what sort of level people are at with this, so I'll start off with some basics and then move on to some of the more technical aspects. So hopefully there's something in here for everyone. So before we dive into ADM, just a brief overview of NGA to provide a bit of context. Next generation audio encompasses a range of audio technologies designed to improve listening experiences. And these tend to be highlighted in 4 fundamental benefits. So accessibility, so this is adjusting a mix to make the narrative more understandable, more easy to follow. And this is particularly suited to people with hearing impairments. We might provide dialogue enhancement to do that, or drop or attenuate less important elements of the mix. And the BBC has done quite a lot of work on this with a technology called narrative importance in collaboration with Surrey University. You might also provide audio description for those with visual impairments. For personalization, so this is tailoring the mix to the preferences of the user. And a typical example would be language selection, but you could do some more interesting things such as selecting your favorite commentator for a football match, or only hearing the crowd noise from your team's fans. Adaptability, so this is the ability to adapt a mix to suit any listening setup, whether it be headphones, stereo speakers, or a fancy surround sound system. But also to the environment. So for example, you might want to mix differently for noisy environments, so perhaps using less dynamic range. And then immersion, so using spatial audio technologies to immerse the user in the story and provide a more realistic listening experience. Now, of course, you can achieve most of this using traditional production methods, but for much of it, you'd need to produce a separate mix for each of the configurations you want to provide. So the solution to that is to take a more object-oriented approach, and that is to send the constituent parts of the mix rather than the fully rendered mix to the end user and perform the mixing and renderings there on their device according to various parameters and preferences. So this is kind of analogous to cake. You could either buy a cake off the shelf, so it's kind of the finished product, which is representative of what we traditionally deliver to end users. Or you could have a bunch of ingredients and various recipes, and it's up to you to choose which recipe you follow to suit your needs. And perhaps there's some leniency in those recipes, so you can deviate from the standard mix if you want something more chocolatey or sweeter. So in this analogy, the ingredients are essentially the original assets of a mix, and the recipes are the accompanying metadata describing how to mix those assets and render an output. So in the NGA landscape at the moment, there's several standardized codecs for delivery, and you'll hear more about a couple of those in the other talks. And we're seeing increasing support for those codecs in consumer devices, which is great because we can now get NGA content to consumers. So when you're producing your content, you need to consider that, particularly these days and into the future, you're going to need to deliver this to different platforms across different delivery mediums and using different delivery formats. And you don't want to have to recreate your content to suit each of these delivery methods. So this is why we need a universal metadata model to describe NGA content, something that's separated from the codecs for the delivery methods that you intend to use, but that can be easily interpreted by software to generate NGA content in a specific delivery format. And this is why the EBU are focused on promoting codec agnostic standards for next generation audio. And we also need to consider that right at the beginning of the media chain in production, it's perhaps not ideal to constrain your NGA content to the capabilities of a delivery method. Because as with all technology, delivery mediums will become more capable and codecs will improve. So you don't want to compromise producer intent at the production stage to fit a specific delivery route. Ultimately, they're going to improve. So you want to retain rich metadata that fully captures producer intent, because future technologies may allow you to deliver a richer experience from the same content. And that brings me on to ADM, or the audio definition model. It's a codec agnostic model for NGA content, and to name just a few of its features, it supports various types of audio asset, and it can share these assets between different presentations of the same content, and it can provide interactivity information. It's standardized in ITU recommendation BS 2076, and this is quite an active area of work. So we're currently on the -2 version of ADM, and with each version comes more feature support in the standard. And when you've got such a versatile and flexible model like the ADM, we have to define some set of rules to ensure a predictable structure for specific applications, particularly for conversion to delivery formats. And this is done through the concept of ADM profiles. So this is how we envisage ADM being used in the media chain. So during production, we'd want to use a production profile of ADM, which provides really rich, verbose metadata to fully capture producer intent. And that makes it ideal for internal use and for archiving. But the problem with ADM in a production profile is that it's almost too unconstrained in what you can do with it. So it doesn't fit into these delivery formats you might be wanting to use. And this is where emission or delivery profiles come in. So they're tailored to the capabilities of the delivery format. So there's an easy and almost direct mapping from ADM in these profiles to the associated delivery format. You'll notice as well in this chain, there's also a route for legacy channel-based emission. And the way this would work is by rendering a typical channel-based mix for a specified speaker layout from ADM and its audio assets. So to do that, we need an ADM specific rendering solution. And this is the EBU ADM renderer, otherwise known as the ear. It's represented by the black speaker icon in the diagram. And you can see that we can use the ear for monitoring purposes throughout this chain, including in production, which is actually where the ear production suite gets its name. But you can also use the same channel-based rendering technique to render different presets for things such as dash or HLS streams, for example. So we've talked a lot about what ADM can do and how we see it fitting into the media chain, but we've not really talked about how it works, how it's structured. And there's far too much to go into in the time we've got, but maybe I'll go over the fundamentals, highlight the fundamentals, and that might be quite helpful. So we consider ADM in two halves. There's the content part and the format part. And you could consider these to be the kind of editorial structure versus the technical properties, such as the format of the assets and how to render them. So in the content part, we have different presentations of the media represented by audio program elements. And these are our top level elements, and they're comprised of audio contents. So an audio content might be narration or sound effects or background music. And under those, we have audio objects. And those are the individual elements of audio that make up that audio content. Each audio object also references the actual audio tracks that provide the audio for that object. And it should be noted that even though they're called audio objects, it doesn't mean they're necessarily of object type. So an audio object in this case is kind of the principle of object-oriented workflows. So it could in fact be a channel-based or HOA asset feeding that audio object. And this is what's described in the format part. So it's a technical description of the audio. It describes the format in which the audio is stored and how it should be processed or decoded. It groups together related channels into packs, such as individual channels of a HOA asset or a channel-based asset. And it also provides time varying parameters. So this is obviously particularly useful for object types where you might want to move that object around a scene over time. So we have dynamic position metadata. Yeah, as I mentioned, there really is far too much to go into in the time we have, but I'd strongly recommend a visit to the EBU AEM Guidelines website. And that covers everything I've tried to go over here, including use cases, structure, capabilities, and things like that. And that's over at adm.ebu.io. There's obviously the specification document itself for ADM, which is BS 2076, but the guidelines are a little easier to digest. So we know what ADM is, we know what the production profile is used for. How do we create content using the production profile? Well, for that you can use the AEM Production Suite, and this began as a project between BBC R&D and IRT under the EBU. And the intention of it is to essentially provide a kind of proof of concept to encourage further adoption of ADM in industry and native support in digital audio workstations. But it also serves as a fairly comprehensive ADM production tool in itself. So what does it do? Well, I've just highlighted a few features here. Obviously, we have ADM import and export support, and we can use this to offer ADM from scratch using various asset types, or to import, then modify and export existing ADM media. We can pull existing ADM media into another session, so it's almost like a merge operation. And this is useful for contributions. And then you can share your assets between different audio programs. It provides monitoring facilities based on the EIA, the EBU ADM renderer that we mentioned earlier. And you can run several configurations of that simultaneously and switch between them, so you can monitor what your content might sound like on different listening setups. It's also compatible with automation. So if you have, say, an object that follows a set path, you can do that with automation in the DAW, and that will be exported in your ADM. The software conforms to the EBU production profile, which is outlined in EBU Tech 3392. And that's based on the -1 version of the ADM specification. For import, however, we also support 2076-2 ADM. We use the BW64 file format. So this is essentially the broadcast wave format with support for 64-bit addressing. Basically, it just means that you can write files larger than 4 GB, and that's standardized in BS 2088. So the first public release went out in 2020, and we've just released a new version this week, which you can download for free from earproductionsuite.ebu.io. There's been a number of fixes and features in this release, but I guess the main highlights are that we now support HOA assets, and we also now have a binaural monitoring plugin with head tracking. And this is based on our BEAR work, and BEAR stands for binaural EBU ADM renderer. This is an early version of Bear, and we're likely to continue to improve on that. So let's look at the different components of the software. The first part of the suite is an extension for the Reaper digital audio workstation, and the extension provides the ADM import and export support within Reaper. The reason we targeted Reaper is that it has a very comprehensive application programming interface, which offers you a lot of control over the software, allowing you to create quite powerful extensions. And it's also relatively inexpensive. Next, there's the AEM Production Suite VSTs, and these are a collection of audio plugins designed for defining ADM audio objects from tracks within a sorry, lost my train of thought there, tracks within your project, and for configuring their parameters, and also for defining how these would contribute to audio programs and create the ADM structure. We also provide monitoring according to the ear reference renderer that I discussed earlier, and the Bear, which we use for monitoring in binaural. And finally, there's an ADM Export Source VST. So this basically enables export from projects that use third-party spatial audio plugins. And it also supports ADM export for traditional channel-based content without having to recreate the project with the ear VSTs. So it's about providing options that don't massively change a user's workflow or require them to recreate existing projects. So it's kind of lowering that barrier, which will hopefully encourage more people to use ADM. And this is how all that fits together. So we have an ADM BW64 file coming in via the Reaper extension at the top. Alternatively, we might be creating a project from scratch. So we have some input plugins on the left, which define our audio objects. And we support object types, HOA, and channel-based inputs. These feed a scene plugin, which is shown there in purple. And this organizes those inputs into audio programs and specifies interactivity data. And then the scene goes on to feed monitoring plugins. And those are in orange, and you can run several of those simultaneously. The scene plugin also feeds the Reaper extension, which allows you to export the ADM BW64 file. So the AEM Production Suite is totally open source, and it's based around a bunch of other open source libraries which are useful for dealing with ADM media. And I won't go through all of them, but this will be shared afterwards. Also, I've listed the standards for some of the technologies we've spoken about. You'll notice something there called SADM, which we've not talked about. But essentially, this is serialized ADM. So this is ideal for live use cases. If you'd like to get in touch with us, you can find our contact information on the AEM Production Suite website. And that also includes a link to a discussion forum on the BBC's MakerBox platform. Okay, so we've got a few minutes left. So I thought it'd be a good time to demo the AEM Production Suite and get a feel for ADM production in a traditional DAW. So hopefully now you can see my Reaper window. I'll just share my.
Looks good.
I'll just share my sound. I think it's already shared. You may need to enable original sound on your end, which is just up in the top left corner. Okay, so we could obviously create a project from scratch, but given the time we've got, I'll just import an existing file. So we have this option, create project from ADM BW64 file. This is provided by the extension. So I will select this, which is a clip from the Eurovision Song Contest. Oh, where's that gone? There we go. So we have basically three assets here. They're all channel-based direct speakers assets. The first one is the main feed. So this is a 4+5+0 feed. And then we have English dialogue, which is just a mono channel-based item, and the same for German. Those go on to feed the scene plugin, and this is where we define our audio programs. So you can see we're sharing the same main asset between the two programs, but it's just the dialog object that's changing. And that goes on to feed a monitoring plugin. In this case, I've just got a stereo monitoring plugin, but we've got a whole range of different layouts that we support. So I'll just give that a play.
Ooh, I'm not the better for that.
So this is obviously the English version.
We're done.
Switch to German.
Typischen Pflasterstein Lissabons sehen wir die israelische Sängerin Netta.
Favorite. This is Netta.
Ihre Stimme mit einer Loopstation auf der Bühne vervielfacht, ist seit März weltweit.
Okay, so I'll show another example now, which kind of shows off the new features of the AEM Production Suite. So this is using a HOA asset and a binaural monitoring plugin. So we captured this with an Ambio microphone, so you can see the signals from the 4 microphone capsules here. They go to feed the Ambio plugin, which does the A format to B format conversion, which then feeds the HOA plugin. And the HOA plugin's been set up for first order SN3D ACN, which is what the Ambio plugin's outputting. That goes through the Sadm plugin and to the binaural monitoring plugin, which is this one here. And as I mentioned, this does support head tracking. So at the moment, I'm wearing a head tracker, which is an NV Sonic head tracker. So this is kind of a DIY one. And there's a repository on GitHub with all the instructions and the software you need to make this work. And this is the software. So I'll just recalibrate my center position. As you can see, this has been set up for the Sparta spatial audio plugins. Basically, we support the protocols used by many third-party spatial audio plugins. We didn't want to start defining our own protocol for this. There's already too many out there. So if we enable OSC now, you can see this is tracking my head movements, so yaw, pitch, and roll. And if we play that back, you should hear the HOA mix being rendered in binaural. Another thing I'd like to show is the kind of merge operation that I mentioned earlier. So if we wanted to bring another ADM file into this session, we just go to Insert, Import ADM, and we'll select this. This is just a really, really simple ADM file, which is basically just noise that pans from left to right. So it's got some really simple automation data there. So I'll just move that into position. And we need to add that into this current program. So in the Scene plugin, I'm going to go to Item and select this new object. And now we should be able to hear that. Okay, and if we just remove the automation, and then I can kind of highlight the head tracking. So delete that point so it's not ramping anymore. So now it's just stuck at -66 degrees azimuth. So now you should be able to hear the effect of the head tracking. So yeah, those are our 2 new plugins for this release. I'll just show you how to export as well. I won't make it go through the whole process because it might take some time, but basically you just go to render as you normally would, and then you select ADM BW64 file and give it a name, render, and away it goes. You just leave it to it and you'll get an ADM BW64 file out of that. So that pretty much covers everything I wanted to cover. If you've got any questions, feel free to ask.
Thank you, Matt. That was great. I'm just gonna get us back in gallery mode here. We have one question, but I believe you've already answered it. That's from Neo. Neo, has your question been answered? It was how can head tracking be used with IMU enabled headphones or external IMUs, but you covered that, I believe.
Yes, so this is basically just an Arduino based one, but things like, you know, there's a lot of these spatial audio headphones at the moment that have the head trackers in, like the AirPod Pros, which is something we'd like to support. Unfortunately, particularly with the AirPod Pros, that API is only accessible in iOS at the moment. So yeah, we're kind of blocked on that for the time being until they release that API on macOS.
Is that something you expect?
I'm not sure. It took them quite a while to expose that API in iOS, so it could take even longer for it to be kind of exposed in macOS as well. I really don't know how long that might take.
We have another question from Nicholas Jensen here. Very interesting. When and where will NGA and ADM likely be adopted and available for the end user? What would a universal metadata format look like in practice if I want to encode or decode a certain parameter in the metadata? There's many questions. Are there free fields or is everything limited to standardized properties? Shall we take one at a time?
Yeah, okay.
Can you see them?
So we're already seeing ADM adoption, and I'm sure the Dolby and Fraunhofer guys will talk about that a little bit more. So ADM isn't really intended to go directly to the end user. It's used to drive emission codecs and delivery codecs. So in that sense, you are getting the features of ADM, but they're presented through the capabilities of these NGA codecs. What the second question was, what would a universal metadata format look like in practice if I wanted to encode, decode certain parameters in the metadata? Okay. Yes, there are standardized properties. These are all outlined in the BS 2076 document, but it is a very, very versatile format. So, I mean, if you kind of look through that document, you'll see just the sheer number of properties you can define there. So it's not just position data, it's things like diffuseness and extent, or the perceptual size of an object, things like that. So it is quite a versatile model.
Excellent. And then producer intent versus customization of the user, how to preserve the intent.
That's a very good question. Yeah, so obviously producers have a very kind of idealistic image of what their mix should sound like. In reality, it's different users have different needs, particularly those with kind of hearing impairments and things like that. So yeah, it's a tricky balancing act, and I'm sure some producers probably aren't so happy with people being able to tinker with their mix and change it to suit them. But I think this is kind of the reality we have to face. We have to make our content more accessible to more users, and also it just helps to broaden your demographic for your content. You know, if you make it more accessible to other users, if you present it in different languages, then yeah, you just broaden your demographic. So there are pros and cons to that, and it is going to be a bit of a balancing act.
Yeah, especially when you don't know what device they're listening back on. There's always going to be room for tweaking things and optimizing for that listening setting that you're in. But let's come back to that question, I think, at the end, perhaps. Una, would you like to introduce our next?
Yes.
Thanks very much, Matt.
Yeah, and we are moving to Dolby, which Dolby Atmos is at least in film and in TV been a standard for some years now, and now that streaming in music with immersive formats also has been a more common thing. Dolby Atmos is also getting into the music industry. So we have David Ziegler and James Cowdery from Dolby who will dive into the whole delivery and ADM process.
Okay, great. Thank you very much. My name is James Cowdery. I'm going to start. David will follow. Going to cover AC4 and just quickly go through AC4 just to give you a kind of basic overview of the technology. And the real kind of meat of it is to really talk about serial ADM. I think that's what people are going to be more it ties in nicely with a lot of what Matt was saying, follows on from that. So I want to kind of focus on that afterwards, after we get through the kind of AC4 introduction at the beginning. So Matt's also talked about, already kind of introduced NGA. One thing some people might be asking is, why did NGA happen when it did? What was the reason behind this? And this was it became clear in about 2013-14 that 4K video was entering, going to be causing a silicon refresh cycle in consumer devices, and so the whole video engines and everything in consumer devices were going to change and be replaced, and so that gave an opportunity to do something new with audio to kind of complement that 4K transition, and that led on to the ATSC3 television kind of competition and format selection in the US, which happened in 2015-16, and then the various countries afterwards have gone through deciding on a country by country basis in Europe what they're going to do with NGA and what kind of approach they're going to take. So Dolby AC4 is an NGA codec. The system has not changed really that much compared with legacy codecs. We've got a couple of new content types that we're adding in. Channel-based immersive, which is mostly used, at least today, for live events. Sports is the big one, but it could be used for other events as well. And then you've got objects, which really finds its place in post-production. In terms of delivery, yes, we've got streaming. Obviously, everybody knows that's kind of come along at the same time, so that had to be worked into all the design work. The codec had to be streaming ready, and also the emergence of virtualization. I mean, it became clear, even though we were immersive was a big part of NGA, that people weren't going to be putting speakers on their ceilings. Even doing upfiring speakers was going to be too much for some people. So virtualization in televisions and headphones is really important, and the codec needs to support that. Now, one thing I want to kind of explain here, because I've seen a lot of confusion on sound forums and so on, is about Dolby Atmos. And what is Dolby Atmos when you're comparing it to codecs such as Dolby Digital Plus or Dolby Digital Plus Joint Object Coding, which is a kind of revised version of Dolby Digital Plus that supports immersive, and then Dolby AC4. Well, there was a change in branding that happened inside Dolby before you had technologies like Dolby Digital. So the consumer was aware of the actual technology that was being used. But given that in different contexts like headphones or different devices, maybe even you're getting a different service from a different network or service provider, different technologies could be used, and this creates a real problem for branding, because the user doesn't really care about that. It's too complicated for the consumer to kind of get their head around, you know, all these different technologies. So the change was to make it simpler for the user and brand the experience rather, as well as the technology, and to enforce the experience to the consumer. And what that means is that you have an experience that is enabled by certain technologies, and you need to worry less about, okay, what technology is being used to give me the experience, but what is the experience that I'm choosing of which Dolby is an audio experience and Dolby Vision is an experience on the video side. So hence it's orthogonal. Dolby Atmos is really orthogonal as an experience to the Dolby Digital Plus or Dolby AC4, which are the technologies that can convey that experience. Obviously, Dolby Atmos is not the same everywhere. Cinema is not the same as listening on headphones, but the intention, which is to provide an immersive or more immersive experience, is the same irrespective of the context. So in terms of bandwidth efficiency, of course, as you'd expect, AC4 is more efficient than previous Dolby codecs by quite a significant margin, and also adds new endpoints, i.e. Binauralization over headphones. In terms of the regional standards in Europe, AC4 has been successful and has got adopted by a large number of regional standards. This is in progress at the moment, so some European countries have gone through their kind of spec rewrite for NGA. There's going to be more to follow later. So that's a kind of continuing process. In terms of attach rate, so is the technology actually in the devices that you buy? AC4 has done really well there, and we're seeing high attach percentages. So even though you can't, everybody turning on their television today is not experiencing next generation audio, that is really still in the future. The technology is in the consumer devices that people are buying today, which means it can be enabled once everything kind of catches up on the upstream side, upstream of the consumer device. So as well as the spec rewrites, there have been various trials that have gone on. These broadcasters that are looking at NGA, adopting NGA, the next step for them has been to do some trials before actually kind of going live full time. And different broadcasters have kind of grappled with different aspects of it. So we have the Roland Garros in France, where they've worked with serial ADM, versus TVP in Poland, where the focus there was dialogue enhancement. Okay, so switching gears a little bit, now I want to talk about production and the problems of NGA that it causes, creates in production. And this is before with 5.1, you really only had stereo in 5.1, and you could downmix 5.1, you could upmix stereo, so you could really kind of have a fixed format through production, or try and use something that looks like a fairly simple kind of format. But that really breaks down when you talk about NGA, because the content types are becoming a lot more varied. They could be switching on the same channel, and you can't upmix a description, an audio description track or a commentary track. It just doesn't exist. So if you're then looking at what the encoder has to do at a program switch, it becomes really complicated. Internal mixing or rendering may need to change, and so on. So to do this without a description of the media is impossible. So as well as on the kind of file-based side, for file-based production of NGA assets, we need this description being presented in real time with the audio over some kind of transport. So this is where serial ADM comes in, and as Matt mentioned, this is kind of an ideal format, and really builds on the progress that's been made on the file-based side with ADM. It can be transported in lots of different formats, and it's had a lot of work on it in terms of standardization to get it to a point where it could be used in production in the future. And the good news is both Fraunhofer and Dolby have put significant effort into trying to make that happen, and we've partnered together on the MXF mapping, and we're also partnering together on the transport of serial ADM over SMPTE 2110 as part of the SMPTE 2110-41, which is kind of new fast metadata transport. So this is all going on right at the moment. The standardization needs to happen, and then that can work its way into the trials and hopefully onto services in the future. One thing I will say about serial ADM, just as a word of caution, is that if for a bandwidth constrained channel, which requires low latency, we may need in the future a more efficient format, something that is kind of binary packed, in order to get those kind of low latency. And we'll see how things go with serial ADM with the current kind of gzipped XML text version. See if there are needs from the broadcasters for something that is more lower latency and more efficient. So that's a kind of open question. So this is just an example workflow that happened, was used in France over the summer with serial ADM. At the moment, because there isn't the support in the partner products, there's a need to just kind of use proof of concept products or special builds in manufacturers' products, get manufacturers together, and then put on a trial for a kind of fixed period of time and try and kind of put serial ADM through its paces. That's where we are at the moment, and we're trying to work with the various manufacturers and partners out there to try and make the transition to support serial ADM. So my last slide, I've got a bunch of resources here that you might want to read and look at if you want to learn more about serial ADM and you want to look at what Dolby has been doing with serial ADM, including there's some free tools which you can have a play with as well. So thank you very much. I'm going to hand it over to David.
Thanks, James. And thanks for the links as well. It may well be, if there's big enough interest, we will ask you to do another session on serial ADM. That would be great.
Okay, hello. I hope everybody can see my screen now.
Yes, looks good.
Perfect. Yeah, so hello, I'm David Ziegler, working from the Berlin office for Dolby, and looking more at the post-produced content creation side of things. So the next 10 minutes will be about an area where actually object-based audio and ADM is used in the industry every day. So where it's actually already has arrived, and this is post-produced content that is streamed through streaming services like Netflix and Disney Plus and so on. Yeah, so quick overview about Dolby Atmos. As James has mentioned, Dolby Atmos is basically a subset of all of these next generation audio features. So Dolby Atmos is basically the immersive and object-based part of this. Yeah, so Dolby Atmos is an immersive sound format. That means we're supporting overhead speakers or a 360-degree component, so that sound can really come from everywhere in the room. And we're using this by transmitting objects. So basically, during content creation, the mixer is able to position objects anywhere in a three-dimensional space, and this is basically making sure that the sound can come from the front, from the back, from the top, or moving across the room and all around the listener. All of these things is done by moving the so-called objects through the room. Okay, so in this instance, objects simply means positioning. So I think before it was mentioned that objects can also be things like an additional language or a hearing disabled track. But in this area of post-produced Dolby Atmos content, where we are right now today, an object means you have a sound effect and you give it a position through metadata. That means you can move it on the x-axis, on the y-axis, and on the z-axis. So you can move it in 3 dimensions and just position it at any position in time. And this way you can very easily distribute an immersive mix. I'm going to explain a little bit how this is achieved today. So we have thousands of studios and edit suites, mixing places where this is done right now as we speak today. And all of them are following this workflow. So in the beginning, you always need your audio workstation where you can have your sounds, and this can be pretty much any workstation. It's mostly Pro Tools in the post-production world, sometimes Nuendo in the audio world. In the music world, it's of course very often Logic. Whatever, you have your audio mix, your audio workstation, and you have to transmit your objects and your BAT, your channel-based audio and your object audio and your metadata into a little tool that is called the Dolby Atmos renderer. We will get to that renderer in a second. And through this renderer, you can monitor. So the renderer sits between your audio workstation and your loudspeakers. So the renderer is connected to your loudspeakers. You have your studio with, let's say, 10 speakers, 12 speakers, or probably even more. So you're monitoring on a immersive loudspeaker configuration. We are very flexible in how many speakers this can be. And you can actually, for pre-mixing, even simply connect headphones. So you can just listen to it binaural. So the binaural representation is also built into this renderer at the same moment. So this way you can mix because you can hear something. And once your mix is done, you of course need to deliver that. So the renderer is able to deliver Dolby Atmos master files. We get to that in more detail in a minute. And it can also actually generate down mixes for you. So if you have to deliver 5.1 or stereo, and it can deliver even stems and M&Es. So everything you really need to deliver as a post-production facility, you can generate in your renderer. So you can easily see that this Dolby Atmos renderer is really the heart of the post-production workflow if you're working in Dolby Atmos. So I'm focusing a little bit on how does this actually work today. So in many cases, the people just buy the Dolby Atmos renderer as a little piece of software from Dolby. It's sold at the name Dolby Atmos Production Suite, and the software costs around $300. So it's really, the plan is not to make this really accessible as easy as possible. So the price is not really high. And this just does all those things I mentioned. You have your input section on the left where you're getting your audio from the workstation. You see how the objects are moving in your room, and you have your output section where it just generates the feeds to all of your speakers and your headphones. Here you see your headphone feed. So this way people can mix, and when they're done mixing, they can push the record button up there and record their master files. This is the current standard solution. And to position all those objects, people are usually using the integrated panning, for example, in Pro Tools. This is how it looks in Pro Tools. You can just use the channel panner in Pro Tools to move your objects around. And this is on the right-hand side how it looks in merging Pyramix, because they recently introduced the same thing that you can also position your objects directly out of Pyramix. So it's deeply integrated into these workstations. You really can continue working with the solution that you worked before. You don't have to learn a new workstation from scratch or anything. And several manufacturers even go one step further now, and they're actually integrating our renderer into their workstation. So if you go back to, if you remember back my slide from 3 slides ago, we have the workstation and the renderer, and several manufacturers are now merging these two things so that you actually have your renderer built right into your audio workstation. So at this moment, you don't need any external software from us anymore. You just have it built in, and you basically see the same functionality, but it is now a window within Nuendo 11 that allows you to control your objects and exporting your masters. And the same functionality we also have introduced in Logic recently, which was very huge for the music mixing community, so that people can mix Dolby Atmos right inside Logic. So you have the window where you're generating your speaker feed, and your headphone feed is just a little plugin inside Logic, basically. Actually not as common in audio post-production, but also very relevant is DaVinci Resolve, which also has the same full integration, so that you can monitor Dolby Atmos right out of the software. Yeah, so these are the tools that the people are using. And once the mix is done, you need to deliver your file. And this is now closing the gap to the subject of this whole webinar about ADM WAV, because really this file format that people are using every day right now to deliver their format, their masters, is ADM WAV. So because there were some questions, where is ADM actually used in this part of the business? It's used every day because it's really a perfect fit for delivering object-based Dolby Atmos. So a Dolby Atmos ADM WAV contains up to 128 channels of audio. So basically the maximum number of objects and beds that you can transport. It includes all those panning metadata, all these metadata I showed you, like basically which object should be on which position, which is actually dynamic, so you can have the objects moving around. So basically at every position in the movie, they can move around. And it contains some additional metadata, some static metadata, which is mainly used to optimize the binaural playback and the 5.1 and stereo down mixes. So binaural metadata to optimize the headphone experience, and trim metadata to have some more influence how 5.1 and stereo is generated from the Atmos. And the very nice thing is that pretty much all the common audio workstations by now support import and export of ADMs. So you can deliver an ADM and just import it into Pro Tools, and you will get your audio and your metadata in a consolidated Pro Tools session. The same actually works for Logic and Nuendo and Pyramix. And you can also export directly out of Pro Tools and Logic and so on without actually recording it first. You can just bounce or export the ADM directly, which speeds up the workflows a lot. And I think this high adoption from the audio workstations has led to a industry-wide adoption. So everybody is using the ADMs all the time. And of course, it's accepted or expected even as the delivery format by all the streaming services. So when you're mixing an immersive series for Netflix or anybody, they want you to deliver the ADM as your master format. Speaking of streaming services, now let's have a little overview over the adoption in the real world. Who is currently streaming Dolby Atmos? This is just a small overview. We also have a lot of local streaming services, but like the big players are really Apple TV Plus, who are doing all of their originals in Atmos and Vision, Dolby Atmos, Dolby Vision. Disney Plus and Netflix, who are doing all of their big tentpole releases in Atmos and Vision. Broadcast HBO Max, which is doing, of course, all the Warner films and a lot of bigger series in Atmos. So it's quite broadly adopted. Of course, it's also part of the Blu-ray spec. So all the feature films are also released on Blu-ray in Dolby Atmos. And I wanted to bring a quick overview how this is actually distributed. So let's say somebody like Netflix is streaming Dolby Atmos. What does that mean to you as an end customer? So what is actually happening in the living rooms and mobile devices of the people right now? So the usual way that the streaming services are delivering this is either through these streaming devices like the Apple TV or the Amazon Fire Stick, or even more common, they run the app on their smart TV. So you're buying a smart TV, it has the Netflix app pre-installed, and then you're using HDMI to connect your smart TV or your streaming box to either a home theater system, something like with actual speakers, or probably more common, a sound bar, which is distributing, basically using reflections bouncing off the walls and the ceiling to create this three-dimensional sound field without the need to actually physically mount speakers. And of course, probably even more common are all of these devices. So we're having tablets and smartphones and headphones and laptops, all supporting Dolby Atmos decoding. So you're basically sending the Dolby Atmos bitstream to any of these devices. You can listen through headphones or through the built-in loudspeakers on these devices. Probably also very interesting is right now we're having smart TVs where the Dolby Atmos decoding or the Dolby Atmos soundbar is basically built in. So they're having small speakers on the top of the television that are firing to the ceiling and generating an overhead component. So you're getting a Dolby Atmos sound right out of your television without purchasing even something like a soundbar or anything. So this gets very mass market accessible. And as James also mentioned, I mean, some of these devices use Dolby AC4, some of these devices, most of them use Dolby Digital Plus, but we don't really differentiate the various codecs and technologies below the surface. It's more like branding the experience so that users understand, okay, I can get access to Dolby Atmos content on any of these devices. Yeah, this is the pipeline, the infrastructure we're looking at today. Similar as James, I'm also having a little link to some more information. This is our Dolby Atmos knowledge base. It's targeting content creators. So if you're running, doing sound design, running a mixing studio, are interested in probably start to work in Dolby Atmos, this is probably a very good first piece of information. It contains a lot of information, articles, tutorials, and a forum to ask questions. That's it from my side. Thank you very much. Guess I'll stop sharing.
Thank you very much. That was great. I wonder, yeah, you're going to send the slides, so we'll have that QR code
Yes.
as well afterwards. Great. Thank you very much, James and David. Rune? Is Rune still with us?
Yeah, I am. Yeah, it seems like your presentation is so clear that there are no questions. So I think we move to Fraunhofer, which is most famous in the industry for the MPEG format, and now have developed further into the world with immersive sound and NGA. So we welcome Adrian and Yannick from Fraunhofer.
Hi, hi Rune, hi Charlotte. Thank you very much for having us here. So we will talk a bit about MPEG-H audio and its relation to ADM workflows, and we'll briefly touch on production tools for that. So I'm Adrian Mortaza with Fraunhofer, working on the NGA standardizations from the beginning when we were writing the requirements back in DVB and ATSC times, and as well as MPEG developments. And Yannick here has been working on NGA productions for many years, and he will give you more insights on the tools that you can use today. So let's dive in. As a very quick introduction, I think you already got the idea of NGA. And obviously, personalization and accessibility are a key component, and that's what NGA brings on top of legacy systems options to increase the level of the dialogue compared with the background, to improve the accessibility. For example, if you have an audio description track, you could not only increase the level, but also move the audio description in the 3D space So you can pan it to the left, to the rear surround, for example. And the person that needs the audio description can sit next to that speaker if you have a discrete speaker setup. And of course, it's very important when you enable the user to do all these personalization options, it's very important to control them. And here is where the MPEG-H audio system comes with the richest metadata set that makes sure that the user cannot go beyond the limits that you impose as a producer. Of course, immersive sound, it's very important as well for NGA. And as you already heard, this brings sound coming from all directions. You are becoming part of the audience. You are not only consuming the content as a, let's say, as a stereo or 5.1 experience, but you have a more embedded experience into this event. And universal delivery, it's also very important. By that, I mean, basically trying to always get the best experience independent of the device that you are consuming the content on. So being that a tablet, a TV set, or headphones, AVRs, soundbars, it is very important to always have a consistent loudness experience and to have the highest possible quality. Let's briefly have a look at the current standardization status for MPEG-H audio. When it comes to broadcast and streaming, it's basically adopted by all major standards bodies worldwide. So it was adopted by ATSC as part of the ATSC 3.0 suite of standards. And back in 2017, South Korea was the first country to mandate MPEG-H, to select it for their terrestrial broadcast service, and also start the regular broadcasting in May 2017. DVB has adopted MPEG-H audio as well, and in the past years we have seen many broadcast events in Europe with MPEG-H audio. So the French Tennis Open was broadcasted over DVB-T2 and DVB-S2 back in 2018 and again in 2019. EBU has conducted a lot of experiments using MPEG-H audio during the Eurovision Song Contest, and many others like NRK in Norway conducting a streaming test with MPEG-H during the World Cup. We will talk a bit later about Brazil that has adopted MPEG-H audio for their terrestrial systems. And of course, all the streaming specifications, including the 3GPP standard that has selected MPEG-H audio for their 360 video streaming service over 5G networks. Talking about broadcast and streaming, what is also very interesting is that MPEG-H audio, it's a single audio system, a single codec that can be used also for 360 reality audio music services. So you may have heard already of this new experience launched by Sony and widely adopted by the industry, which is actually built on top of the MPEG-H audio system. So there are many services available today from Amazon Music, Unlimited, Deezer, Nugs, Tidal, Sony Select in China, and so on. And there are many devices today supporting MPEG-H audio, especially when it comes to the AVRs and soundbars. So when you want to have an immersive experience using a soundbar or an AVR, it is essential to get all these discrete audio channels and audio objects to the end device. So if you have a TV set connected to an external AVR, you don't want to do any down mixing, any processing with these devices, and especially you don't want to change the codec. So that's why it was very important for the MPEG-H ecosystem to ensure it's supported already in end devices. And this is already done, and looking forward to many more in the future. This is a quick overview of the songs available in the 360 Reality Audio catalog. This is an old slide. There are many more already today. I think it's more than 10,000 songs, but that's not really important. It's important that the producers already have experience with immersive music, and they know how to create and enhance their productions and deliver it to the existing streaming platforms. going back to broadcast, I think the biggest news from the past few weeks are coming from Brazil. So I will give a quick overview of the broadcast overview of the Brazilian market. And in 2019, they have standardized something called TV 2.5. TV 2.5 enables broadcasters to use next generation audio on the existing platform, broadcast platform. So they, for the last 20 years, Brazil is using, a bit less than 20 years, it's using AEC stereo and 5.1 for broadcast. And now they can simulcast by adding an additional audio codec for offering an enhanced, immersive and personalized experience. And MPEG-H audio was adopted back then as an optional codec for this TV 2.5. The first live production was done by TV Globo during Rio de Janeiro Carnival in 2019. And in the same year, they already broadcasted for the first time MPEG-H in Brazil during Rock in Rio. And this was a broadcast over ISDBT, over 5G, and also a streaming test over HLS. Since then, last year in December, Rede Amazonica was the first broadcaster in the northern part of Brazil to start regular broadcast with MPEG-H. So they have enabled it on their Amazon Sat terrestrial channel, and this is used 24/7 today. The most important aspect for them was not the immersive experience, but the personalization options. So what you see here, it's a simple user interface, which offers the user the option to switch between a default preset and a dialog enhanced version, and also have an option to manually adjust the level of the dialogue between the limits done in production. And this was very important. We were discussing a bit before we started this webinar. It was very important for the producers of Rede Amazonica to be able to enable all these options with a minimum effort. You don't want to add one extra day to producing NGA to their workflows. And if I'm not wrong, basically they managed to do this with something around 10 minutes added to their stereo production. So you order a stereo mix, you offer this with AEC, and then keeping the dialog as an option, as an object, you offer the option to enable dialog enhancement. This is a very brief diagram of the workflow that they use today in Brazil. So you see here that there is something called the MPEG-H authoring unit, and Yannick will briefly talk about this in the second part of this session, which is able to create all this metadata in live SDI-based workflows. Of course, this can be done over IP in the future, but today it's already reliably used in SDI workflows for the past 5 years, delivering all the metadata with configuration changes, ad insertion, and so on. And for the end user, there are always two streams. One, it's AAC that can be decoded by all devices, and then there is an MPEG-H audio stream that can be decoded by newer devices and offer the enhanced experience. And now moving to the latest project done by the SBTVD Forum in Brazil, the so-called TV 3.0 project. This is an enhancement similar to ATSC 3.0 or to DVB-T2 in Europe, where they will offer a non-backwards compatible upgrade of the system. So what you see here, it's a basic architecture of all the components of the broadcast system, and they have launched a call for proposal in 2020 to select new technologies for the transport layer, for the video coding, for audio coding, and so on. And when it comes to audio coding, they have set the most detailed requirements for next generation audio system selection, including advanced personalization and accessibility options, configuration changes, metadata authoring, all of this in live broadcast. Hybrid delivery, including over the air and over the top. And what is very special about this project is that they have required a feature evaluation phase. So they have appointed an independent test lab, which was in charge of evaluating all the proposals and they had to do evaluation of the end-to-end chain from the production down to the living room. Everything had to be evaluated in real time, and this is probably the most advanced test procedure for NGA feature evaluation. So looking back to last year, there have been 3 audio proposals. So one AC4, AVSA, and MPEG-H audio. And as I said, all of these systems, they have been evaluated by a test lab appointed by the SBTVD forum. And after all the test and evaluation period, and of course, considering all the market data, a single audio system has been selected for TV 3.0 in Brazil, and that is the MPEG-H audio system, which will be now used as the mandatory audio solution for broadcast and also for streaming according to TV 3.0. The broadcast is planned to start in 2024. So all the preparations are ongoing to get ready for this new broadcast platform. And what is very interesting is that the test report describing all the performance of each system, it's publicly available. So I encourage everyone to click on this link and read all the details and all the requirements that had to be fulfilled. And basically the MPEG-H audio system has been the only proposal that meets all the TV 3.0 requirements and was able to fulfill all these test cases in live broadcast scenarios. Now, going back to the diagram that you've seen earlier, what you see on the lower part, this is basically the future TV 3.0 platform. And you see, of course, the transport layer is different. The physical layer will be different. But the good news is that the MPEG-H production will stay the same. So for broadcasters, they don't have to create multiple productions for legacy and new productions for MPEG-H audio. For TV 3.0, you can use the same authoring unit, the same workflow, and there are already video encoders available with MPEG-H support with all the capabilities of MPEG-H that can do already today the TV 2.5 and TV 3.0 in the same time. So for broadcasters, it's very important to reduce the investment and not replace every single device in their workflow whenever there is a new feature to be enabled in the broadcast chain. So now I will hand over to my colleague Yannick, and thank you very much to Matt for introducing ADM and giving a very good overview of what ADM means. We'll jump now into the relation to MPEG-H and to the production tools that can be used today. So Yannick.
Yes, hello. Thanks, Adrian, for the introduction. Hi, everyone, also from my side. I'm happy to have you here and interested about ADM and ADM workflows with MPEG-H. So in the next 10 minutes, I'm going to tell you a bit more about ADM and the workflow using MPEG-H in production, especially for live and for post-productions. So let us getting started into the topic, just as a brief recap on what we have already seen. So basically, ADM as an audio definition model defines an application agnostic metadata format. So that means it's actually independent from the final emission codec we are going to use, be it for the various applications, such as for broadcast or also for music. But actually ADM is kind of, can be a lot of things. So we actually never really can expect or don't know what to expect from this ADM format. So here it comes, the importance of so-called ADM profiles. And this ADM profile, they defining actually which configuration of ADM makes sense for specific applications. So we are basically reducing the degrees of freedom as needed for the various applications. So basically we have an ADM, which could be a lot of different things, but as soon as we have an ADM profile, then we know actually what this ADM metadata are carrying and what it includes. And then we actually can also send this through a pipe, more or less, an ADM interface, and then we can put this into emission encoders, send it out. And all of these profiles, or the majority of profiles, they are also part or subset of the I2R recommendation. And of course, one of the important ADM profiles is the MPEG-H ADM profile. And the ADM MPEG-H profile is transparent with the features of MPEG-H audio. So whenever you create an ADM file in the MPEG-H ADM profile, it's compatible with the whole MPEG-H audio system. And it's designed to work in post-production, but also in live productions. And live production, then it's a serialized version of ADM, the so-called SADM. What that means, we're also going to cover in the next slides. And what's really important is that this ADM format, this MPEG-H ADM profile, is compatible with other MPEG-H master files. So we have to differentiate between live and post-production, because live and post-production, they have different production scenarios, different requirements. But the ADM metadata and the MPEG-H production format, so the MPEG-H master file, this is what I'm going to explain you also in a second, they are totally compatible and can be converted back and forth without any problems. So if you want to know more about this profile, please feel free to visit the website, download it, and you can dig through this whole profile, as it's an open source profile, and you can get some details on that. When it comes to production of ADM or an MPEG-H master in general, there are several tools available. And what I would like to emphasize is the MPEG-H authoring suite, because it's a free of charge software bundle. So we really want to enable the production of MPEG-H and next generation audio with ADM for everyone. So we offer this bundle for free, and it consists of an authoring and monitoring tools, either for live, sorry, not for live, but for standalone or post-production applications in a plugin, or we can convert different ADM profiles, or we can also have quality control tools, so we can monitor and watch like video and audio together with interactivity settings directly on our production facilities before we finally send it to an encoder. And here we have a short example of or a screenshot of the MPEG-H authoring tool, a tool set which is a standalone application which allows the authoring and monitoring of MPEG-H metadata. And the export is an MPEG-H master. And an MPEG-H master could be either a so-called MPF, MPEG-H production format, or an ADM file, BWF ADM. And let's have a short look on what the differences between this MPF and an ADM file is. Because, as I already said, we have different use cases, we have different applications, and this requires different workflows. So the MPEG-H production format is actually a file which contains the metadata we define during productions. So our authoring with various interactivity settings, with prominence sliders, with different presets for user selection, everything modulated into a timecode light audio signal. So when you listen to that, it sounds like audio timecode, but it actually is this metadata. And this is then carried in a PCM audio track together with our audio signal, for example, over AES-free compatible interfaces. So for example, we just have it in an SDI or MADI stream together with with our audio essence, maybe even bundled together with a video. So we can always ensure that our metadata and the video and our audio signals are bundled together and synchronized to each other. And it's very robust. It can even survive sample rate conversions or level changes, as it's just a regular audio track. And on the other hand, we have BWF ADM, and that separates basically the audio essence for an audio stream, for example, in IP streams in ST2110-13, together with the metadata in -41 for serialized ADM for live production and IP-based workflows. And this is still in the standardization phase, but the development from our end is actually more or less finished. So we even showed 1 year ago a presentation on where we had an all-over IP workflow with serialized ADM, sending the signal from a production side to a final emission encoder where it was broadcasted. And I just wanted to emphasize, also in interest of time, because we're running out of time, unfortunately, that this conversion between MPEG-H production format, so you remember this control track thingy, the timecode-like audio signal, and ADM is fully interoperable. So we can switch back and forth as much as we want without losing any information. So we are always we are able to produce content in the format which we think is currently best for our production facility, but we are future-proofed as well. So maybe we are broadcaster, fully rely on SDI-based infrastructure currently. And in the future, like in maybe 5 to 10 years, we're going to switch to IP-based workflows. That's actually no problem because this file format can be converted without losing any information and is fully interoperable to each other. So it always depends a bit on the situation. MPF currently is very good for SDI-based workflows, can be also used for post-production content exchange and archiving, while ADM is more towards archiving and content exchange, but can be also used for post-production and live broadcast IP workflows. So for example, in Brazil, they are currently storing or producing in MPF, and maybe in the future when they switch to IP, they can just convert all their archived material from MPF to ADM and can send this out over or use this in IP-based infrastructures. I would also like to emphasize the MPEG-H conversion tool part of the MPEG-H production, the MPEG-H authoring suite, because we can convert from different profiles into MPEG-H profiles, or ADM profiles. So for example, there are several tools out there from new audio technology, spatial audio designer, there are Auro 3D tools or tools of the MPEG-H authoring suite, as well as the ear production suite in future versions, or even Dolby Atmos ADM files can be converted into an MPEG-H ADM master or MPEG-H master, be it ADM or MPF, depending on the current infrastructure. So I would like to emphasize one more time the production workflow. So from an audio production side, you can use several tools. You export an MPEG-H master, the quality control tools available. You can archive this signal or send this master file, be it ADM or MPF, to an encoder and send it out to receiving devices. There are several tools available. So MPEG-H is an open standard. We don't offer only one solution. It's actually up to you and to manufacturers to apply for this code, to adopt the codec. So there are several tools out there and plugins to be used, new audio technology. DaVinci Resolve from Blackmagic Design has a native integration of MPEG-H audio, and there are also tools for producing 360 reality audio. That's the 360 Walk Mix Creator by Sony. And for live production, we have tools for hardware units, which can do the same thing as we can do for post-production in real-time scenarios from younger audio, from linear acoustic, and also from new audio technology. And for everyone who has more questions now than answers, I hope that's not the case. But I would also like to motivate you to watch our tutorial series where we really go into the details and explain you how to produce content for live and for post-production using the tools available. And as a quick switch over to SADM in the last 1 or 2 minutes, I would like to hand back to Adrian. And Adrian, please give us some insights about SADM.
Thank you, Yannick. Right, so we talked a lot about ADM today and briefly mentioned SADM, and that is of course very important to find solutions on delivering this metadata, so this so-called chunked ADM over over the broadcast workflow, so that you can make use of all these features. And of course, you could do that, for example, using SADM in AS3. So AS3, it's a legacy format. It's not ideally suited for SDI and IP transport because it has known issues like data capacity constraints, error robustness, synchronization, signaling. So we all know back in the days when people wanted to use the metadata fields of SDI, there was always an issue with the synchronization. And thus, this can be only an intermediate solution for SADM transport, for experiments, for trials, for learning more about how to use SADM. And of course, SMPTE already works on a specification in the ST2110 suite of standards on how to deal with SADM over IP. And I think that is the future. So in this ST2110 world, you have different IP streams. So you have one IP stream for video, one IP stream or more for audio essence, using the 2110-30. And also you have an IP stream for the metadata according to 21-41. So the standardization of -41 is still ongoing, and I hope it's getting really close to an end. So hopefully we will see it published very soon. And this is a future-proof solution for SADM carriage in IP workflows and enable it in live broadcast without any legacy issues. I think we will hopefully have follow-up sessions to focus more on SADM topics as well as ADM hands-on productions. And I thank everyone for attending the session and looking forward for questions.
Yeah, it seems like many of the questions has been answered through the presentation here. I want to follow up on one of the questions, which actually is why music producers are a little bit slow to get into immersive formats than film sound. That's actually something we're going to talk about in a week when we have 2 music producers and one who is mixing for streaming service for Netflix, and they're going to talk a little bit more into how to make content into immersive formats and some of the issues. And I will say one of the big difference is that we have been doing surround for film for many years now, I would say over 40 years. So there have been some long research into kind of how to use it in the film narrative. And I feel that, and that's also a thing we are working at the schools at the moment, is that you have to kind of when you compose for immersive formats, it's another way to think than to stereo. And it's pretty, I would say, a steep learning curve for composers and music producers. Morten Lindberg, who is going to be join us next week, he said that it took his 10 years just to move the musicians from sitting in the classical thing to actually sit in something which makes sense in immersive format. And then now he is learning the composers to start to compose in immersive formats. I'm not very fan of upmixing. It's nice, but if the immersive formats is going to kind of have a breakthrough for the audience, I think it has to be kind of a new way of listening experience, a new wave of expression. Then I think it's going to be successful. And also next week, also going to talk about some of the other questions here. I mean, why is when you have Apple Music playing to the receiver, I have that at home. It plays nicely Dolby Atmos, and when I turn it on the phone, I hear just the Apple spatializer, which is something different. And I know this is a big issue for producers like Morten Lindberg. I think my own questions you have answered very well. I actually have one question. Is this this is to all of you? Is this going to be like the end of channel-based audio, and are we going to move to only object-based audio? What do you think?
So maybe I take this one first, since I was the last one presenting. Yeah, I think that's not the end, because what we have seen in most of the productions of immersive sound in live, for example, the Eurovision Song Contest, for creating an immersive experience, there were around, I think, more than 100 microphones on the arena, placed in different positions, and all these microphones were used for creating the 5.1 mix. And for the immersive experience, actually, there was a height layer added in order to capture the reverb of the arena, all the ambience, and used together with the existing microphones. So there is not really a major change when it comes to channel-based production. So objects are extremely important, especially for personalization and for accessibility. But in terms of sound production, staying with channel-based, that is still probably the best way to capture the ambience, and it will stay for a long time.
Yeah, I tend to agree. I think that, I mean, with the democratization of media creation and huge varying of production values that can go from very high to very low, you know, user-generated content, there's always going to be a place for really simple audio and the simplest, you know, stereo. Stereo is not going away. I think it's going to be here for a long, long time. I think the interesting thing is the emergence of creating audio that is of audio elements, splitting out the audio elements and delivering that, compared with delivering the final mix. That opens up a tremendous amount of possibilities and potential, which we've seen.
Great, thanks.
I know we've gone over time, but can I ask another question? Which was, oh yes, you mentioned, both of you, that we can convert from all of these different, between all of the different formats, but what is that doing to the quality of the audio, and what do content creators need to be aware of whenever they're, or can they just freely convert between them all? I guess it's a question for both Dolby and Fraunhofer.
I mean, basically the ADM WAV is lossless audio plus metadata. So if you just take some of that information and repackage it, it's a lossless process. So most of the time it's not a problem for the quality of the audio. It's more like changing some parameters of the format of the container.
Okay, it's not the same as down mixing or in re-encoding. Yeah. Okay. Thanks a lot.
If I may add to that, that's the value of ADM profiles. So that ADM, it's a great tool, but it really requires profiles to make it interoperable. And of course, these profiles, they might have different features. So that's why we have so many profiles, because each system has slightly different features. And if one feature is not supported in another profile, then of course the conversion, it's only one way. So you will not be able to reproduce the same feature in when you go back to the original ADM profile. So that's the things that you need to care of. Of course, the audio is not destroyed, but the metadata, all this conversion back and forth, you need to know what you're doing. So make sure that you author in the widest range possible, cover all the features, and then just before distribution, do the conversion in the format that you want to use.
Yeah, so it's not lost along the way.
It's not exactly.
I see. Thanks. I've actually got a lot of clarity from this webinar today, I know. So thanks a lot to all of you. We have gone over time, but I see you've answered a lot of questions in the chat. So I think we should wrap it up for today. But thank you very much to you all. I'll go through all of your names: James, David, Yannick, Adrian, Matt, and Bruno, for also joining the conversation. And yeah, please do join us next week if you're available. It's going to be another good discussion with some great producers. Yeah, the last thing I want to say is you don't need to, but it would be great if you could fill out our questionnaire. It will be sent out in the follow-up email, and we're also going to send the presentations and recording, so you can share it with your colleagues if someone couldn't make it today. So thanks a lot, everyone.
Thank you very much.
Thank you so much for inviting us. And I think if there are follow-up questions, it's fine to forward at least my email address, because I'm dealing with content creation questions all the time anyways.
Yeah,
So
we will do
probably-
so, and we'll share your contact information in the follow-up email. Yeah.
Amazing.
Thank you very much, everyone. Have a great evening or the rest of the day.
Thank you very much.
Thank you.
Thank
Bye.
Bye.
Bye-bye.
Bye.